Good afternoon, everyone. Welcome to the Artemis Biosolutions webinar on understanding chemical disinfectants and using them properly for pandemic response. My name is David Baker. I'll be your host as we hear from Michael Pinto, CEO of Wonder Makers Environmental, a team of experts based in Kalamazoo, Michigan, helping people solve environmental health and safety problems. Michael Pinto has over 40 years of experience as an environmental health and safety professional. He holds multiple professional certifications and is the author of more than 240 articles and 6 books, including Fungal Contamination, a comprehensive guide for remediation, and Forensic Restoration, procedures to protect operators and occupations. Michael Pinto is a renowned expert in his field, and we are honored to have him join us today to discuss how you can use chemical disinfectants properly for pandemic response. Hello, Michael.
Hi, David. Thank you for that nice introduction. I appreciate it very much. Before I go too much farther, I did want to mention to the participants of the webinar that if you have any questions, you can actually put those in the chat box during the course of the webinar. David is monitoring that. If there's any that are really exciting or something like that, he may interrupt me and we can deal with those during the presentation. Otherwise, we'll catch them at the end, and then after the ones that come through the chat box, we'll open up to general questions at the end as well. So with that, let me just point out that I appreciate the introduction that David did. Being an expert in the field just means that you've lived a long time and kind of hang out there. What I'm perhaps proudest of in terms of this particular presentation is that since the very beginning of the pandemic, I have been part of a small group that's been called the Joint Task Force, and that is a collaboration between the Restoration Industry Association, the IICRC, and the American Industrial Hygiene Association. And in a collaborative fashion, in kind of warp speed, if you will, that group and the Joint Task Force has now on the 5th edition of their instructions for restoration contractors to deal properly with the COVID-19 situation. So with that, I think I want to jump right into the material. We got a lot of material in a short amount of time today, so be prepared to move along smartly with me. So what we're going to cover today is symbolized by the picture in the background here. It's a beautiful waterfront. That's Positano, Italy. If you ever get a chance to visit, you'll enjoy that immensely. But that's the idea, is that we have a whole raft of information that we're going to cover, and I've organized it in such a way that it should make common sense to you. We're going to start with the rationale for using disinfectants. We'll actually talk about the types of disinfectants that are out there. That will lead us right into the discussion of the EPA registration and what some of that means, particularly in regards to COVID, since there's only a handful of products that are actually screened against COVID, and we'll explain why. Then we'll talk about the nitty-gritty, items 4, 5, and 6 there. How do we apply the disinfectants? What tools do we use? And how do we do that within that standard of care? We will be talking specifically about some of the recommendations in that Joint Task Force document that I mentioned previously. Now, just to make sure everybody understands, this presentation is designed to be educational. It is not just a marketing program for Artemis. However, since they are our sponsors and they have some really good products, we are going to talk about those at the end. But with that, we wanted to make sure that it is educational throughout. So let's just jump right into it. The first thing that we're going to cover is a rationale for using disinfectants. And if you look at the slide there in the center is your COVID-19 causing virus, which is officially known as the SARS-CoV-2 virus. But around the outside, you'll see other pictures of different sorts of microorganisms. And disinfectants are used in food service to prevent salmonella. They're used in healthcare situations, not just for the virus that causes COVID, but bacteria and virus that cause infections. And healthcare acquired infections are still one of the leading causes of death in the medical community. And so using disinfectants properly is a big deal for us. Specifically today, meaning where we are in the world today, we use the disinfectants because the COVID-19 is the gorilla, the giant gorilla in the room. Everybody's focused on it. I'm based here in Michigan. Our governor just put into effect this morning additional restrictions on movement of people and what sort of businesses and things can be open. That's supposedly a 3-week step back to more cautious approach to it. But what that means is that we're going to have businesses that are closing and opening. We're going to have businesses that have people that come in that test positive. Everything that goes on in the next few months that is going to help us bring people back to a sense of normalcy is going to include some level of cleaning and disinfecting services. The logo there on the right of the screen, this is a little scary to me because you can see there's marketing folks who will say, hey, we can just take your company name, we can slap it in this advertisement, and you can be good to go to put these powerful chemicals, just spray it around everybody's house or their businesses and things like that. And we just want to make sure that people understand that is not the right approach. So we'll share some of that as we go through. The other thing I want to mention today is that's today, but there's a real reason why we have been disinfecting and quite honestly, why we have the expertise today to deal with the COVID-19 pandemic a lot better than we did, say, in 1917 with the Spanish flu and things. And part of that is because, one, we have better tools, and that includes the disinfectants and particularly the Artemis ones, but also the knowledge that comes from dealing with many of these situations in the past. This is not our first rodeo, so to speak. Even in my lifetime, the Hong Kong flu, that's going way back when I was like in middle school. The swine flu, the avian flu, what was known as SARS, the severe acute respiratory syndrome, which actually was much heavier influence in Canada than what we experienced here in the United States. The Middle Eastern respiratory syndrome, the SARS-CoV-2, the one that we're dealing with right now, the COVID-19, is somewhat of a variation of those SARS and MERS viruses. So the good news is that we have some experience in terms of how we deal with some of these things. The bad news is that we will be doing this well after the pandemic. We will be disinfecting in the future for lots of reasons. One is because there's pretty good sense from all of the medical professionals that we're never going to defeat, so to speak, with quotes around it, the general influenza. There's so many different variations every year. The transmission throughout the world, we're going to deal with it. We will treat it. We'll do our best to deal with it, and that's going to involve cleaning and medical care, but it's also going to involve a lot of disinfectants just for the flu. Probably to me, the bigger reason, though, is that people's expectations have changed. I happen to be in the business. I'm at the tip of the spear in some respects on some of these issues. But the fact of the matter is that when people get used to having offices cleaned on a more regular basis and having disinfectants used as part of the cleaning process, and they're just not going to stand for going back to the old days where one person gets the flu in the middle of the winter, and the next thing you know, you've got 10 or 12 or 24 people in the same office that come down with the flu. That's just not going to happen. And certainly the elder care facilities and some of the other ones are just going to be more aware of what they need to do to prevent that sort of problem in the future. Which then brings us to the idea of other specialty areas. So regardless of the season, regardless of whether it's the flu or whatever, there are individuals in our society. The miracle of the medical community these days is that people that just would not make it, infants that are born with serious health defects, elderly that are immunocompromised, individuals that have had heart transplants and heart valve replacements and things like that, they're compromised. Their immune systems are not as strong as the average person. So these are going to be individuals who need additional care, and their environments need additional care. And that's where the judicious use of disinfectants comes into play. And that brings us, of course, just to the whole idea of disinfecting chemicals. What are they? How can you use them? You know, the photo I have there on the left is one that I put there on purpose because most people are nervous about chemicals. You know, all these things are designed in a laboratory and they're, you know, kind of not natural. And the reality is a fair number of the disinfectant chemicals are not only very safe, but also very natural. And we're going to get into that as we move forward here. But let's start by taking the disinfecting chemicals and talking about the people that make them, essentially the chemical industry, the disinfectant chemical industry. What a lot of people don't understand is that there's really two fairly distinct markets. There's what we call the consumer chemicals and disinfectants, and that's going to be, you can see the pictures there, you know, the ones that are on your store shelves and that you can buy just by going into the grocery store or into Target or Walmart or something like that. That is, they're targeted for the consumers. Now, those can be very good products, but a lot of times because of who their market is and risk to the users and things like that, they're either older technology or sometimes they're not quite as strong, if you will. The commercial disinfectant market is a little bit different. And you've probably heard the term hospital grade disinfectant. Those are quite honestly, when you get into that category, those become ones that have enhanced what they call efficacy, or the ability to deactivate different viruses and microorganisms to a greater degree than some of these other items that are out there. And the interesting thing in this pandemic situation, and that's the picture on the lower left, there's been such a need for some of the consumer, and there's such a shortage in the consumer market, hand sanitizers and things like that. You've probably seen the articles and you know, programs on TV and reports and everything about distilleries actually, instead of making whiskey or making vodka or something, generating the alcohol, creating the ethanol and the alcohol and putting it into hand sanitizers. So fortunately, Artemis uses a non-alcohol system, but that again goes back to the fact that they're a commercial grade manufacturer of disinfectants as compared to, you know, just strictly consumers. Now, when we're talking about disinfecting chemicals, we do want to make sure that we start at the beginning here. Historically, soaps are your, and detergents are going to be your initial disinfecting agents. And then the application of specific disinfectants into the soaps, and the Dial antibacterial soap was the first one back in the late 60s, I believe. That actually gives you the cleaning action of removing things from the surface with leaving a residual disinfectant that can help with prevention of the transmission of diseases later on. Once you move out of soaps and detergents, and particularly ones that are not enhanced, you get into probably the most common disinfectant chemical compound, which has this kind of weird name, quaternary ammonium compounds. And again, I put the chemical formula up there, at least for one of them on the side, because that looks cool, right? That's chemistry, and this is all woo, this is all neat and whatnot. But the reality is that quaternary ammonium compounds have really changed our lives over the last 150 years in terms of starting to figure out, even after the end of the Civil War, how to do different types of microbiological kill. And then that first in the medical community, primarily with the surgical centers and things, and then even into our household areas today. And so I said a few minutes ago, you know, we're in a lot better spot than we were in 1917 to survive the COVID-19 pandemic, just because of some of the things that we've learned over the last 100 years. So these quaternary ammonium compounds can be used either singly or in conjunction with other materials. but they do work even on slightly dirty surfaces, and that's why they tend to be used for most of the hospital and elder care cleaning facilities and things like that. Once you get past quaternary ammonium compounds, the standard that most people rely on or historically have relied on is bleach. The technical name is sodium hypochlorite. I think it's fascinating. I actually wrote an article probably almost 20 years ago now that said why professionals should not be using bleach, both for mold remediation and also for general disinfection. And the reason is that although the bleach is pretty good, the sodium hypochlorite is pretty good at deactivating microorganisms, the bleach itself gets deactivated very quickly by contact with other contaminants. So if there's any soil load or if there's anything like that, it's not very good. And so I was fascinated this time in terms of this particular pandemic, where yes, the EPA and CDC and other folks are still saying that you can use bleach, but if you look closely at their recommendations, they are saying that you should only use bleach if no other disinfectant is available. And I think that's a real recognition on their part that it has significant problems with it. And just in order to try and be cool and stuff, I did find, as I was looking for different illustrations of bleach, that apparently it's also the name of some Magna cartoon series or something like that, which is why that's there. And I have no idea what that's about, but I thought I'd put the picture there because, again, it makes me sound like I'm cool or something. When we get past quaternary ammonium compounds and bleach, there's other what we call oxidizing disinfectants. And the term oxidizing just means that there's a unstable molecule in there that's got an extra oxygen atom, and it wants to give up that oxygen atom and bind with something else. And typically when it does that, it releases energy, and it's that energy, if it comes in contact with, let's say, a virus or a bacteria, that energy then breaks the shell a lot of times and is what actually creates your disinfecting power. So bleach is clearly an oxidizer, but so is hydrogen peroxide, probably the most common one and the safest one. And the reason for that is that the hydrogen peroxide will break down into CO2 and water naturally once it's exposed to the air and put on surfaces and things like that. So you
Michael,
have this.
Sorry to interrupt you. I have a quick question. We have a couple of questions about log3 and can you call a log3 a disinfectant or a sanitizer?
Well, so let's talk about what log means. So there you can see on this particular slide, when you are talking about the kill rate and you're talking about 99% kill rate, well, that sounds pretty good, 99 out of 100. But when you're talking microorganisms where there could be millions per square inch or whatever on a surface, killing 99% of them may not actually be very good. So then you start getting into the decimal points, 99.99, 99.999. And rather than just keep repeating all those nines, typically the shorthand is to count the number of nines, and then that tells you on a logarithmic scale how many things are being killed. So that's why you have this 99.9999. So that's going to be, I'm sorry, that should be a 6 log kill. I should have put another 9 in there. That's my problem. So if there were 6 nines in there, that would be a 6 log kill. And yes, the questioner is absolutely correct. To actually earn a designation as a sanitizer or as a disinfectant, you have to have a certain level of killing power on the microorganisms on whatever the test organisms are. And so typically a sanitizer is going to be a 4 log kill. So that would be 99.99% effective. And disinfectants typically are 6 and 7 log kill. So you're getting way out there. Essentially, you're leaving 10 out of a million viral particles or bacteria on a surface that are live, theoretically, if you're using a 6-log kill. All right. Was there anything else, David, or are we moving on?
Oh, no, that's it. Move on. Thank you.
Okay, good. And a great question, and it helps to understand. And more importantly, as many times as I looked at these slides, I'm embarrassed because, as I said, I've got 6 9s there instead of 7 like I was trying to. All right.
It's a lot of 9s.
So anyway, we're talking about some other chemical disinfectants that are out there. There's a number of them depending on what direction you want to go into and whether they're used primarily in hospitals and that sort of stuff. You can see isopropyl alcohol is listed there. There's idiophores, which are iodines and phenolics and all that. Probably the one that gets the most attention these days as competition to some of the other more standard chemicals are the natural oils, like the thyme oil there, which is an extract from the thyme plant. But again, if you're trying to just go natural, many of the ones that use the hydrogen peroxide are going to be as natural and as green, as you will, as other ones. So that's why we talk a little bit about the Artemis products at the end here. They typically are proprietary blends of both the quaternary ammonium compounds, the hydrogen peroxide, and a benzyl ammonium chloride. And all of this was developed essentially by the U.S. military in their Sandia National Laboratory. We'll talk about that at the very end of the program. Some other options that are out there instead of the 2-part mixes, because when you have hydrogen peroxide, you have to kind of keep that stable, so you end up with a lot of 2-part mixes on that. But other products that are out there can be the ready-to-use products that are a lot of quaternary ammonium and surfactants and things, as well as some of the non-alcohol hand sanitizers and things. Those are also available from Artemis. So with that, and trying to move right along, we do want to talk about our third category here, which is disinfectants and the EPA. And the chart there is actually a very good one. That is from the CDC and their coronavirus, and they cooperated with the EPA to help with that. And essentially what you're saying there is that, there's a small list that you should go through when you're going to deal with a disinfectant. Is it EPA approved? Do you understand how you're supposed to use it? Actually read the label directions. Hard for us men to do that, right? Then almost all of them require some sort of pre-cleaning of the surface, and then allowing the disinfectant to sit on the surface for what they call the appropriate contact or dwell time, and then protecting yourselves and protecting people from the chemicals later on. So with that, let me just cover a couple of basics here about, again, the whole process. It is the EPA, not the CDC, that regulates these disinfectants. And their primary concern is that they're used properly. That means according to label directions, and that we're not hurting people. You don't want to make the situation worse by, having children or pets or something end up being poisoned by these, because when used properly, they're very safe. Obviously, if people are drinking them or something like that, that could be a problem. The other thing that the CDC and the EPA came out with is the whole idea that at the beginning of this, because there's a toilet paper shortage and there was a this and that shortage, people started hoarding or stockpiling disinfectants. And that's a little questionable. A lot of these products do last several years, particularly in the concentrate format. But the difficulty is, why would you want to stockpile it and keep somebody else from using it that needs it, particularly healthcare organizations and stuff? And because the supply chain, certainly in the United States, did a great job catching up and providing product as needed. So just rely on your vendors. Having a few months a supply on hand is pretty typical for a lot of restoration contractors and building managers and janitorial firms and stuff like that. but do you need a 2-year supply of disinfectant because you might run out? And the answer is no. And that's because, like I said, the supply chain is caught up, and the EPA is catching up as well. They are certifying slowly individual products against COVID-19. Now, the interesting thing is that even if a product doesn't have a specific COVID-19 registration, it doesn't mean that it can't be used. As a matter of fact, the EPA has this list N, you can see it there on the slide, and that is based on what they call an emerging pathogens program. So, give credit where credit is due. The Environmental Protection Agency got caught flat-footed with some of these pandemic style illnesses in the past, or at least epidemic style illnesses in the past, and realized that if it's a new pathogen that develops from nature, we may not have, or we don't have chemicals that are tested against that specific pathogen. And so they developed this program called the Emerging Pathogens Program. And essentially what that program is all about is that if the chemical is proven to be effective against the class of organism that the new one is in, so this COVID virus is a SARS style virus or a human coronavirus. It's an actual variation of what they call a human coronavirus. Well, if your label and your testing has shown that your product is good against that, you can literally put it out there and advertise it as effective for the SARS-CoV-2. And so right now, there's only, like I said, what I'm aware of is 4 or 5 different products who have actually tested against the SARS-CoV virus, because if you think about it, that means that laboratories have to handle that virus and there has to be testing against it and all that. And that just puts even laboratory people at risk. So many of the products that are out there that are being used and used effectively against the virus that causes COVID-19 have not been specifically tested against it, but they have been tested against the human coronaviruses. And so that is what the EPA says is good enough. So with that, we kind of have additional questions perhaps later about the EPA registration and things, but we want to talk about the application of the disinfectants. We're going to talk about it in 2 major formats, as you can see from the pictures. How do we apply it on surfaces as part of a cleaning process? And then how do we apply it, what I call broad scale, as you can see there, through a fogger or a mister or whatever. So again, let's just pause for a second and say, why do we apply these disinfectants in the first place? And there's lots of reasons. The big overall picture, of course, is that we're trying to reduce the number of microorganisms in the environment, but we're doing that for a reason. You have somebody that tests positive in your work environment, and you want to, make sure that that's not going to spread. We have people that are going to be coming back to work, and we want to have some documentation that the facility is as good as it possibly can be for them to come back to work. And it's just going to be, as I said earlier, particularly going forward, it's just going to be part of a cleaning regimen. So that typically is going to be applying the disinfectants on what I call a broad scale basis. You can see from those pictures, spraying it around. The other reason that we apply it is as part of the cleaning process. Instead of just using soaps that are effective at physically removing even dirt and microorganisms, if we use a soap and we use a disinfectant at the cleaning stage, even if our cleaning isn't perfect, we then have the benefit of the residual disinfectant that can help us. So again, we're substituting some of the disinfectants in as part of a cleaning regimen, and then we're applying it, as you can see on the lower picture there to the left, with the airless sprayer or fogger, just so it does its work on its own. So now we know kind of when we apply them and why we're doing it in general. The question is, what is the marketplace for these, and where should we be applying them, whether we're a building owner trying to make that decision for our team members, or whether we're a contractor that's offering those services to different folks. Here's some of the ones that need it right now. Assisted living and/or what I call elder care, businesses. We talked about that on a number of occasions now. The sports venues, the schools and the classrooms. One of the interesting things, we were working with a local school district and they had a need to bring a classroom back online. But because they have a policy of going through and quarantining classrooms after one group of students have been in there before another one comes in, at least 24 hours, they didn't have that 24-hour window in this particular case. And so by applying a broad scale disinfectant, they were able to essentially speed up that quarantine. Now that brings us to the actual disinfection application process. And you'll notice I have taken this particular section of the material and broken it down into sub-steps so that you can follow along. And the first step, as we just talked about a moment ago, is the cleaning has to happen first. Most of the instructions on the disinfectants tell you that they're to be applied, if not to a clean surface, a relatively clean surface or something that isn't significantly dirty. And that is because we've got to get the disinfectant to actually come in contact with the microorganisms. And if the microorganisms are covered up by dirt or somehow hidden from that chemical, then it's not going to do as effective a job as it would if it's just the remaining microorganisms on the surface. And you know, it's kind of pick your poison, if you will, in terms of how you want to do some of that cleaning. In the restoration industry, HEPA vacuuming is very common, but damp wiping or some combination of that. I would say if you do any sort of spray and wipe or damp wiping, we are strongly recommending that you use the combination cleaner and disinfectant to make that happen. The second step of the disinfection.
Michael, can I interrupt you for a second? We do have a couple of questions. Can you use normal janitorial rags for touch point cleaning if you wash between the uses? Can you just use those normal rags?
Well, if you're using them properly and you're laundering them properly, you can. I would point out that a lot of the janitorial rags these days are microfiber, and if you're going to wash microfiber, there's a very specific process for washing them so that you don't damage them. If they're just cotton cloth rags, that's fine, but make sure that each surface that's getting wiped, what we're going to talk about here in just a moment, is that you can take a towel and do a double fold it once, fold it a second time, and that will actually give you 8 clean surfaces. But that means that that towel should only be used on 8 surfaces. So if you look at a room, you've got a doorknob, you've got a light switch, you've got a computer keyboard, you've got a tabletop, you've got arms on a chair. If you count that out, you're probably going to use more than one rag for every, even a small office. And that's why a lot of people have moved towards some of the disposables, just because the volume of towels that you're using in a situation like that, if you're using them properly, jumps up pretty geometrically almost. So, but that's exactly what we're talking about here, how to sanitize those touch points or clean those touch points. And whether you're using the washable towels or whether you're using the disposable, you do, like I said, want to make sure that you're wiping one item with each clean surface of that towel. And that takes a little bit of practice and a little bit of training and a little bit of supervision. But you know, once you think it through a few times and practice it, it becomes second nature. The next step of the application process after we get done with the initial cleaning then is going to be the actual broad scale application of the disinfectant. So again, it's a follow-up to the cleaning. It's less focused. We're not dealing just with the touch points. We're you know, going to apply this disinfectant to a whole number of different surfaces. But by doing that, it'll be more comprehensive. Typically, even with the safest of products, we prefer to have the broad scale application done in an unoccupied facility. And that's just because anytime you're atomizing different materials, you just want to be careful about that. The person who's going to be doing the application of the disinfectant, as you can see there, has some respiratory protection on. The other thing that's important about this is it really is a part of a process. It's not a silver bullet. You don't just go in and fog everything. That's very similar to what we're showing here in terms of the broad spectrum disinfectant, what I call the sizzle versus the steak. And what I mean by that is that to do this right, it isn't all that sexy, right? You're applying the disinfectant, as you can see in the picture on the left, that's got the green check mark above it. That's the right way to do it. You're applying it to different surfaces. The picture on the right shows people fogging the air, almost like a commercial for a TV show or something like that. What a waste of chemicals, you know, what a way to put people in danger and not really be very effective. The issue is not necessarily the microorganisms that are in the air, because as they circulate through the air, they end up landing on the surfaces and then typically staying there. So that's what we're trying to clean, and that's what we're applying the disinfectant to. That brings us, of course, to the different ways to do that and the disinfecting tools. This introductory slide has most of the methods there. You can mop it on, you can wipe it on, you can spray it, and we're going to jump right into those. The simplest tools to use are the manual tools. Something as simple as a trigger sprayer on a spray bottle, pump up garden sprayers. All of those can be effective tools for applying a disinfectant. Remember, these can be used in both stages. You can be using these as part of the cleaning stage, the first one, and then later on as the broad scale application of the disinfectant. I would, however, suggest a trigger sprayer, you know, for spraying a whole office or something like that could be a bit much. Go to the garden sprayer, go to the airless sprayers, things like that. The powered tools are coming up next, and the first one we want to talk about are airless sprayers. Actually, a lot of history here with paint style sprayers, and with the right tip and the right pressure, airless sprayers can be very effective in terms of applying these disinfectants. They tend to leave bigger wet droplets, which means that a lot of times you can do one single pass and get the surfaces wet for the appropriate amount of contact time or dwell time. Some of the other powered tools include foggers and different types of sprayers. These ULV, or what they call ultra low volume ULV foggers, you can see there. That's one of the ones that is recommended for a number of the Artemis products, and many others as well. The difference here is these foggers, you can adjust the spray a little bit, or the application method, but they typically are smaller and lighter droplets. You typically have to get a little bit closer to the surface than you would with an airless sprayer. And you want to be careful. A lot of times it's a two-pass system rather than a single pass, because if you put it on too heavy from an ultra low volume fogger, a lot of times you'll get running and drips and things like that. One of the pieces of mechanical equipment that you have to be careful about using is electrostatic sprayers. I know they've gotten a lot of press during the pandemic here, and everybody wants an electrostatic sprayer, blah, blah, blah. This is such an issue that the EPA is looking at this very carefully. Number one is that most of the products that are out there that are the standard and even the commercial grade disinfectants have not been tested in electrostatic sprayer. And when you actually start putting either a positive or negative charge on the droplets that are coming out the gun, you can actually screw up the chemistry. And so if it's not specifically mentioned in the label directions that that's a approved application method, you would want to stay away from that. They've got some additional impact on the electrostatic sprayers here. As I said, they're not rated for a lot of these chemicals. Some of the electrostatic sprayers actually have a switch or a button on them where you can shut off the electrostatic portion of it and actually use it as a sprayer. The reason people like the electrostatic aspect of the sprayer is that it helps the chemical droplets actually adhere or bind to the surface. But if you're doing that and sacrificing the actual effectiveness of the product, then that's not a good that's not a good trade-off. Regardless of whether you can use these products in electrostatic sprayer or not, if you're going to use one of those sprayers, I would encourage you to make sure that you're educating your client about that, because as I said, there can be some drawbacks to using it as well as some benefits. So with that, we're going to jump to our sixth section, which is the application in conformance with the industry standard of care. The picture there is the cover of the latest document that's available in regards to the recommendations to the restoration industry for applying these disinfectants. It is actually real guidance. It is a consensus document. It's the closest thing we have to a standard right now in the industry. Probably the best in part of it is it's free. If you go to the Restoration Industry Association, the RICCC, or the IICRC, sorry about that, and the AIHA website, all of them have links to it, and you can download that for free. Anybody who has a question or just needs something even simpler than that, send in a question to David here, and we can email you a copy of that, no problem. The interesting thing about this guideline, and I'm not trying to pat myself on the back just because I was part of the Joint Task Force, there's lots and lots of people that have been involved in this, is that it really is fairly thoughtful and intentional as to how we apply these disinfectants. There's sections in there about preparing the area, applying them in a logical pattern, assuring dwell time, and even making sure that we're not creating more problems by stirring up dust when we do it. And I'm just going to take the next 4 slides and walk through each one of those individually here. So if we start by preparing the area, probably the most important thing is make sure that return air vents get covered before you start spraying any sort of or applying any sort of disinfectant. The number of items that can be put into an HVAC system is very limited, and you don't want to cross-contaminate that HVAC system. If the system needs to be cleaned or sanitized, then it needs to be done according to the NADCA, which is the National Air Duct Cleaners Association, and the ASHRAE recommendations. So just, again, avoid spraying stuff in the HVAC system. I would also say make sure that you're not spraying sensitive electronics or fogging even computers and televisions and things like that. You want to be a little careful about that. So once you've got the area prepared, then you have to think about the operator. How do we prepare him or her? And that is with the use of proper personal protective equipment. What specific equipment gets used? Anything from like an N95 filtering face piece to a whole, a full face respirator with cartridges and things. That's going to depend on the chemical and the application method. So we've got our area prepared, we've got our people prepared. Then we have to start thinking about preparing the area from a ventilation standpoint, because if you're going to be atomizing through a sprayer or through some sort of fogger, you want to make sure that we're not causing problems that way. The CDC recommends that we open doors and windows. That's a little dicey, particularly up here in Michigan, as we're now getting down into the 30s and things. You just potentially are going to screw up your temperature controls and things in buildings. So more and more people are relying on HEPA filtered negative air machines or filtration machines, and even now floor fans with some of the special filter material. And if anybody wants additional details on some of that filtering material, again, just shoot it in as a question and we'll get that out to you after the program. But there's ways that we can move the air around to make sure that the residual disinfectant that we're trying to spray on surfaces isn't just becoming a contaminant in the air itself. Once we have the area and the people all prepared, then we have to think about preparing the product. And that involves proper measuring if it's a concentrate or a mix where you have to mix the two parts. Use a measuring cup. Don't just do the old, yeah, it looks about right. The other thing to remember, and I can't tell you how many times I've run into this, is people think, well, if it's a concentrate and it says to use 2 ounces to a gallon, if I use 10 ounces to a gallon, I'm going to be 5 times as good. No, you won't. The issue is going to be mix it according to the label directions for what you want to do. Once it's mixed, get it into your sprayer, fogger, whatever it is. Don't overfill it, and then make sure you're setting your controls properly before you start spraying. As you go to spray, you need to have either an awareness of when you're starting to spray and how long the surfaces are staying wet, or have a associate with you that watches that. That's the biggest thing. What is the dwell time? How are we keeping that set? So as I talked about earlier, you may have to do multiple passes, a little bit lighter rather than one heavy pass, so that you don't get a lot of residue or streaking. You want to be careful of the buildup of the residue. A lot of surfaces, are going to be very amenable, so to speak, to the disinfectants. But certainly most glass, windows, mirrors, you want to probably plan on polishing afterwards, because most of the disinfectants will leave a residue. Sensitive surfaces, electronics and papers and fabrics and artwork, very, very careful on that sort of stuff. I had a contractor that ruined a chalk artwork one time by applying disinfectant to it, and you can imagine how that went. From a perspective of protecting the company that's doing the work, as well as the company or the organization that's having the disinfectant applied to it, just make sure that anybody who's doing this sort of work looks at their business liability insurance, make sure that they actually have coverage. You'd be surprised how many general liability policies will not cover something like this. And then even if you have insurance coverage, make sure you're explaining it properly. The language, and this is laid out very well in the Joint Task Force document, is that the contractors are doing the cleaning and application of disinfectant. They're not, and this is unfortunately what the EPA and the CDC talks about in their documents, they're really not cleaning and disinfecting, because to disinfect means that you're actually measuring the kill rate on the surface. So again, the disinfectant helps to break that chain of infection. We're controlling the spread of the disease, but it is just a single tool in the toolbox. You can't just spray this stuff around and say, well, there, I don't have to wear a mask, or I don't have to keep socially distant, or I don't have to wash my hands anymore, or anything like that. It is just part of the process. And I want to emphasize that with one last slide in regards to the technical material here. And that is, as I said, it is just one step in the process. The use of application or disinfectants for both cleaning and for broad scale application are just part of the process. And if it's not being used with some of the other things that we talked about, sending sick people home and wearing masks and keeping ourselves socially distant and putting barriers in place if you've got retail situations and stuff like that, you're not going to be effective just relying on the chemicals as a one and only magic product. A lot of technical information. I do want to take just a few minutes, if you can hang with me here, to talk about some of the Artemis products, because they are excellent products, and they are available to help deal with this situation. The first thing I wanted to mention about this is that they are, the primary ones are the bio-oxygen line of products. And these are typically two-part systems. I mentioned earlier, they're this whole combination of pretty safe ingredients that then turn out to be very effective, was developed by the military through the Sandia National Laboratory out in New Mexico. And basically what they were trying to do is figure out, how do we deal with decontamination of some of these biological and chemical agents without using a chemical that is so bad that it's going to be worse than the chemical agent that the enemy threw at us. And once they had that for the military, and they've got their military grade of it, they realized this is okay for, not just okay, this is great for the real world. And so they've licensed different vendors, a handful of different vendors around the country, to take these formula and then develop their own products. And Artemis is definitely one of those organizations, and these Artemis products are now being used worldwide. I think it's interesting, and people have asked me the question quite a few times. They know that I have worked with Artemis and helped to evaluate some of their products and that sort of thing. And they said, well, why do they call them bio-oxygen? That just seems like a weird name or a funny name or something like that. And the answer is because, again, it's an oxidizer. It gives off that extra oxygen atom from the molecule, and that's what helps to break everything down. And it works really good against the biological contaminants. And so that's how you end up with a bio-oxygen. But the cool thing is, again, they're using, things like the hydrogen peroxide, which is found in a lot of household products, everything from makeup to food supplements and things, first aid materials and stuff like that. So you end up with this list of products that is very good against these contaminants, but they're non-toxic, non-corrosive, and basically very green. That's one of the things that makes them different. And the difference is because most of the traditional disinfectants and stuff, they're either based on bleach, chlorinated solvents, or other, hazardous or corrosive materials. The phenols and the iodophores, the iodines and stuff, those can actually be very corrosive. The other interesting thing when you get into some of those other products is that they tend to work against certain types of organisms, whereas the bio-oxygen line, again, think about what the military was trying to do. We have to have basically one product that's going to take care of decontaminating all sorts of chemical and biological products, and that's what the bio-oxygen line does for you. So that's really how they're different. Some of the specific products that are out there, they have a chem decon, as you might suspect, coming from Sandia. That was the first thing. Their Santa Cloud is what is often sprayed or fogged. The mold is designed, and all of these are slightly different formulations. I tell you, the people that did the design on this or did the actual development on this are pretty sharp. They understood what the hazard was, and then they tweaked the formula so that it's most effective against those sorts of things. So, for example, the bio-oxygen carpet and the bio-oxygen laundry, both are fabrics that they're working on, but there's different fabric fibers in carpet than there typically is in laundry. And so by adjusting that formula a little bit, they get it to the point where it's the most effective for those particular items. When you get to the ready-to-use products like the Artemis Defender disinfectant, that's a cleaner disinfectant. The big difference here is that is stabilized and that's ready to use. And you can see it's EPA registered on a wide variety of things, including because it was against the human coronavirus, it's now appropriate to use for the SARS-CoV-2 as well. And this one is one of the ones that they recommend for that cleaner disinfectant. So the first step might be you use this to clean your touch points on the microfiber or on the rags, and then come back and follow up like with one of the bio-oxygen products. Last but not least, in terms of specific products, I did want to mention, because I'm fascinated by this one. This was an early jump into the market for the Artemis folks, their Bio 40 TB. And a lot of people just do not understand that tuberculosis is still a major problem in terms of a infectious disease that's out there. And if you can kill TB with your disinfectant, that's on the upper level of a lot of these different products. That's why this is a hospital grade material and kind of the big gun, if you will, if you have a major issue in your facility or you need some real help with it. Whew, a lot of material with that. I think we had a couple of questions throughout, but Dave, don't know if you have any more questions you want to throw at me here.
Michael, thank you so very much for that thorough explanation. We have a lot of questions that have come through. I don't think we can answer all of them. I think one thing we can do is commit to sending out a follow-up to everybody who's participating today. You'll get a link to the replay of this webinar. We'll have a couple of attachments. The COVID-19 pandemic from the IICRC, I think, would be helpful, and maybe there's some other resources, and maybe even some answers to some of these questions. But maybe we can answer just a couple of the questions. There's a number that have asked about testing. How can you determine if it's effective? There's not a real easy way to determine, like pre-post treatment. How do you determine how effective you are at treating a room?
Yep, got it. So early on at the beginning of the pandemic, that was going to be much more dicey. We didn't even really have a good understanding of what the SARS-CoV-2 virus was. There were hardly any labs that were prepared to look for it. We now have lots and lots of environmental labs that know the DNA signature of this, and it can be as simple as literally taking wipe samples and sending them into the lab and having them do the analysis. So certainly that's the most effective way, right? Is wipe ahead of time and see if there's any SARS-CoV-2, and then wipe afterwards and see what your difference is. The difficulty with that, quite honestly, is that as much as we have a pandemic and everything, if you're not in a hospital sort of situation where you have a cluster, or maybe a nursing home where you have a cluster of potentially impacted individuals, the likelihood of taking a 4-inch square sample somewhere and finding that SARS-CoV-2 virus is going to be pretty low. So most of the testing that's pre and post, they're negative before and then they're negative afterwards. So I'm not sure what that tells you. My approach and what I recommend, it's less expensive and it's faster and it's immediate turnaround, is use what's known in the industry as an ATP sampler. You take a swab, it measures general biological contamination. And if you can get down to single digits or 0 on a lot of these meters, that just means that all of the biological material is gone. It doesn't discriminate. It doesn't tell you whether it's a bacteria or a virus or SARS or whatever. But if it's gone, it's gone. So at anywhere from $2 to $5 a swab, once you purchase a meter, that's a really cost-effective and really good way. And it offers immediate feedback, particularly to the people who are doing the cleaning and the disinfecting. You do the cleaning, or prior to that, you get a reading of several hundred. You do the cleaning, you get down to 50. You wipe again, you do the disinfecting, you're down to 10 or 2 or 1. That process helps people understand what they need to do to get those surfaces clean. Dave, I can't hear you at this point.
Sorry about that. We have just a couple more questions I want to ask now. We'll send the rest out with the Q&A to the audience.
Sure.
One of the questions that keeps coming up is treating sensitive areas. So your computers, a tablet, computer systems. What guidance or ideas, what thoughts do you have on how to treat those kinds of environments?
Yes, well, 2 things. First of all, and again, not trying to be a shill for Artemis or anything, but one of the benefits of having like a bio-oxygen product is that you're not going to have as much residue when you get done. It breaks down into the carbon dioxide and the water and everything. Now, the difficulty with electronics is that water and electricity doesn't mix. So even though it's light droplets and it's a light fog and everything, even though it's a single pass, you're probably not going to blow up a computer to if it gets hit with some fog or something like that. But if you do that, repeatedly, that's part of like a once a week or twice a week process. you can damage those electronics over time, just because a little bit more moisture might build up in there, and then there is some residue that the moisture holds, and the next thing you know, there's a one of those microelectronic circuits is being shorted out or something like that. So the general rule of thumb is just don't grossly apply the disinfectant to an electronic screen or something like that. If you have to, put it on a rag and wipe the keyboard and stuff like that, just because the fog and the sprays tend to penetrate so far.
Great. Well, Michael, thank you so much for taking time. Other comments here say fantastic presentation and amazing info. So clearly the audience feels similarly. Thank you for taking time. For those of you on this webinar, you can go to Wonder Makers Environmental at wondermakers.com to find out more about Michael Pinto and his organization and the wonderful things that they do. And if you're interested in Artemis Biosolutions, go to artemisbiosolutions.com or send an email to sales@artemisbiosolutions.com or call 630-359-4090. Thank you all very much. Michael, thank you for a great presentation, and thank you for helping us make a fresh, safe world.
Thank you, David. God bless everyone. Bye-bye.
God bless. Take care. Thank you, everybody.